right, well then let's rock and roll. So in the previous lesson, we spoke about the parabola, and we spoke about how a parabola has different forms. So the one form of a parabola is called the standard form, and it looks like that in its sort of fancy algebra form. But in its sort of number form, it could look, maybe I'm making this up, like plus x plus 3. Okay, so that was the standard form of a parabola. And we learned about the 5-step process for drawing a parabola. Can anybody tell me what one of those steps were? So let's try and get the 5. You can put them in the chat, or you can put your hand up and we can hear from you. What are the 5 steps for drawing a parabola? It's always good to do a bit of revision. So Annie has said the first one is shape. Exactly. And that's determined by the number in front of the x squared. So this would be a happy parabola or concave up parabola. Segabatso, what do you remember?
Good afternoon, sir.
Hello.
I remember that we first have to find whether the graph is a happy face graph or a sad face graph.
Perfect. Yes.
The
What
second
step?
step, we have to find the y-intercept.
Okay. And we have to make it.
The third step, we have to find the x-intercept.
Okay.
The fourth step, we have to find the x symmetry.
Perfect. Can you remember the formula for that?
Yes, sir. It's x is equal to negative b over 2a.
Cool. You remember a lot. Last step.
The last step, we have to find the turning point where we have to substitute the x symmetry into the equation.
I am very impressed. Thank you so much. I could not have said it better myself. Okay, so that is the 5-step process for drawing a parabola. However, sometimes parabolas don't get presented in standard form. They come in another form. And this form is called what? Who wants to tell me what this form of a parabola is called? Who's feeling like they're going to share some of their wisdom and their knowledge with us? Can we unmute Masejo? Simon, for some reason, I've got too many things on my screen, so I can't get to the...
It's called the turning point form, if I'm not mistaken.
Turning point form, yes. And can you tell me, can you remember what the letters and the variables that are involved here?
I think it's x plus 2 squared.
Okay, I'll give you a hint. It's got
A.
Yeah.
Yeah. Then maybe x plus p. Yeah, x plus p.
Yes. And
then plus q.
So squared plus q. Yes. This is the turning point form. And thank you so much. That was fantastic. So this is the A. It's the same A that's here, and it affects the shape. Then what does P affect? Who would like to tell me what P affects for the turning point? So let us unmute. I've got lots of things on my screen at the moment. Let us unmute Teguvatso.
So the P shows the horizontal shift.
Yep, horizontal. And what about the Q?
It shows the vertical shift.
Perfect, perfect. Okay, guys, we're almost ready for today's new stuff, but I want to add in one more thing. There's something called the root form of a parabola, which is going to make an appearance today. And it's very simple. All that it has is it has an A in front, and it's the same A that gets all the attention in the other ones. And we go x minus x1, x minus x2. And I want to ask, does anybody know what this x1 and x2 are? Maybe your teacher's spoken about it, otherwise I'll tell you now. But this is called the root form of a parabola. Any ideas? Okay, so because it's called the root form, x1 and x2 are just the roots of the equation, or they are the place where the parabola cuts the x-axis. They might be here and here. So maybe it could be like -1 and 3. And when we use the root form, we often use it to find the equation of the parabola. Okay, now one last thing, and then we are going to get going. If you're given the turning point form of the parabola, you can get the turning point, the actual turning point, straight from the turning point form. And the way you do it is you go minus p q. So you take whatever's here and you put a negative in front of it, and then the q from here. And so sometimes when you want to get step 5, when you want to get the turning point and the axis of symmetry, if they give you the turning point form, sometimes you get it really quickly without having to work it out from scratch. Now, there's probably quite a few new students in the house, but I just want to do a quick little vote. If what I've explained now and gone over makes sense to you, give me a thumbs up. If you feel a bit lost, give me a thumbs down. Okay. Awesome. And remember, if you do feel lost and it's your first lesson, you can always go back and see the previous lesson. And we're going to consolidate this today. So it's not like we're leaving it. We're going to come back to it fairly closely or fairly soon. Okay, now, today's first little skill increase is here are 4 parabolas, and these parabolas are written in the turning point form. And I want you to work out, so let's call this A, we'll call this B, we'll call this C, we'll call this D. If I wanted to find the turning point of this parabola, I could break it down and change it into standard form and then use minus b over 2a, but that would take a long time. And since I've learned this new trick, what I'm going to say is the turning point is minus 2 and 1, or I'm going to say the turning point is just 2, 1. And in that information, we know the axis of symmetry is just x is 2, because it has to be this number. And this saves you a lot of time. Now, if there are questions, I'd like you to raise your hand, but for the rest of you, I would like you to work out the turning point for B, C, and D for me. Okay, so go ahead, find me the turning point for B, C, and D, and if you have a question, put your hand up and we can have a discussion. So Ayanda, I can explain again. So if I want to get the turning point from the turning point, so if you look at this graph here, it's got the A, and then it's got x plus p, but the p is minus 2. So I guess it's like, that was the standard form. And what I'm saying is that actually, you can just take this bit and put a minus in front of it, and then take this bit, and you get your turning point, which is going to be 2, 1. And that's a property of this. Now, I want to know, can you work out the turning point for this one over here? Well, I think following this pattern, this is going to be x is minus 2, and then the other part is minus 1. So that's the turning point for B. Where is the outside negative coming from? It's coming from the property of the parabola. So whenever something is written in, I'll show you now when I sketch a graph, but for now, you just have to learn when you're getting the turning point from the turning point form, you always change whatever this thing is over here, you put a negative in front of it. So if it was negative 2, it becomes positive 2. If it was positive 2, it becomes negative 2. It has to switch, but the y will stay the same. For now, I just want you to learn that. I'll show you when I sketch some of these graphs now quickly, it'll make a bit more sense. Okay. And then once you've got your answers, pop them in the chat. Okay, I see the answers coming through. So the turning point for this graph is 2, 7. What's D gonna, oh wait, it's not, yeah, it is 2, 7. Aha. And what's the last one gonna be? And Annie says it is 2 minus 7, and I agree, Annie. Okay, so why did I want to show you this? I wanted to show you this because I wanted you to know if they give you the graph in turning point form, it's actually a lovely gift because it saves you working out steps 4 and 5 the long way. And so if they give you the turning point form, you can smile because it saved you some work. I also want to show you now kind of what's going on inside this graph. So we said earlier in the lesson that this -2 is a horizontal shift, and it's going to be a horizontal shift to the right. And then we said here, this would be a vertical shift, and this would be 7 units down. So if you imagine the most basic parabola in the world, which is y equals x squared, a happy graph, it looks like that. And its turning point is at 0, 0. This graph over here, its turning point is going to be at 2 minus 7. And let me show you how it gets there. So if I go x minus 2, this graph has to shift 2 units to the right, and then it has to move 7 units down. And so the graph itself is not going to be like the blue graph. Its new turning point is going to be over here. And what's then going to happen is this whole shape is just going to be going something like that. And so this is why you can still, if you wanted to with this graph, you could work out the x-intercepts and the y-intercepts. But I just wanted to show you that even though, oh, I went the wrong way. Wait, x minus 2. Sorry, I went the wrong way, everyone. Let me reverse. Sorry, I made a bit of a mistake there. So if it's -2, it has to move 2 units to the right. It moves the opposite direction. For when it's this, it moves the opposite direction. So it goes 2 units across, and then it goes 7 units down. And that will be my turning point. And so then it would look something like that. So notice how it goes. And that's why the turning point has to be 2 minus 7 when it used to just be 0, 0. This is what we call shifting the parabolas. Now that's a bit tricky, but I thought I would show you guys because you've been doing very well. Can I just get a little vote? If votes, thumbs up if you understand that, thumbs down if that was a bit confusing to you. Let the people speak. Okay. It's nice to throw in a little bit of something about the journey. Okay, now here's one more little sneaky question. We're focusing on this graph D over here. If I ask you, what is the range of this parabola, the green one, which is the function h, who would like to tell me what the range of the function h is and where would I look? I'd love to have a little discussion with someone. Who would be willing to share their thinking with me about, if I look at the green graph, which is h, what is the range of the green graph? And what do I mean by when I say range? And you don't have to get it right. I just want to hear your thinking. Okay, let's go to Kuhotso. I'll unmute Kuhotso. What do you think the range is, Kuhotso?
I think the range will be y is greater or equal to -7.
Hit it out the park.
Or we can say that y is the element of -7 and infinity.
Ah, so okay, so there's 2 ways we can write this. We can write it using interval notation, which is -infinity to -7, or we can write it like this. And all that the range is asking what y values are valid for this graph. And if you look at this graph, this happy face only gets down to the turning point. It never goes lower. And so the range is just the y values that are above that. So y must be greater than -7, but it can never be, or equal to -7, but it can never go below that. And this is another question that they like to ask you about. They ask you about domain and range. And so I just wanted to clarify that with you as we did that one. I'll talk about that a bit more later in the lesson. Okay, everyone, you've done really well. I want to move on to a next part of the lesson. So here is the process for finding the equation of a parabola. And I'm going to do an example, and then you are going to mimic me. So it says here, determine the equation of the parabola for each of the following. And I'm given 2 points over here, which are the x-intercepts, and I'm given another point which is on this parabola. And you can kind of see this parabola has been shifted across and down. Now, I don't know how much it's been shifted across and down, but I can clearly see it's done that. So we're going to use this form, and I'm going to write y equals a x minus 1, x minus 5, and put it into root form. Then I'm going to use this point, minus 112, and I'm going to use it to help me find what a is. And the way I do that is I put a 12 where there's a y, and I put a minus 1 where there is an x. I'll just highlight that for you. Can you work out for me what the a value is? I want everyone in the room to try and find what the a value is. So then pop it in the chat. What do we think? What do you think a is going to be? I don't know. I haven't worked this out ahead of time, so you're going to have to help me. Minus 2, and that is minus 6, which then gives me 12. So a must be 1. Yeah. Okay, now how does this help us? Well, when we started, we needed to know what this value was. So now we do. And in order to get the standard form of my parabola, I'm going to multiply that by that. So I'm going to get x squared minus 5x minus x plus 5. I know I'm going a little bit quickly, and that simplifies down to y equals x squared minus 6x plus 5. So that is the equation of the parabola that you see over here. Okay. So the way we find a Rosario is that we plug in the other point that we are given. So what I'm going to do now is I'm going to leave this on the board, and I want you to find me the equation of this parabola down here. So I'll leave what's on the board so that you can look at it, and I'll try and make this a little bit bigger. Find me the equation of this parabola, and you can mimic the method that is up here if you feel unsure. Where does the 5 come from? If you look at this original question, you will see that there's a 5 over here. So there's a 5 there, and there's a 1 here. These are what we call the x-intercepts. And so those have to reappear in here because of the root form. And that's something you just have to learn. Okay, Masejo, I see there's a question. I'll come to you now. Let me unmute you. What's your question,
Hello, sir.
Masejo? Okay.
I wanted to ask if there by the equation of y equals to a open bracket x minus x1 and x minus x2, if we write the other one on the other side, I don't know if you understand what I mean, but if I take x2 and write it on x1, is it going to change?
No, it'll be fine as long as you've got both. So as long as if you've got, I think what you're saying is if you've got this. Is that what you're saying?
Yes. No. I mean, when we're looking for the, what do you call it? The A, when we're looking for A, and
Yes.
then you put the coordinates
Yes.
of x2 on x1, is the answer still going to be the same?
Okay, so when you sub in, the 12 has to go to the y, right?
Yes.
And the -1 has to go to the x. And if both the x's get -1, so
Yes.
this will work out exactly the same as this one here.
Okay. Thank
We can
you.
even do this one together if you like. So tell me what's my first bracket that's going to look like.
It's going to be -1 minus 5 when
Oh, no,
you
I mean,
switch them.
yeah. No, I mean for the new question. Can you see the new question? So I've got an x-intercept here, which is -1, and I've got an x-intercept here, which is 4. Could you help me with this bracket?
So the bracket is going to be 2, if I'm not mistaken. 2 minus
Okay.
1.
Okay. Now the problem is that you're on the right track with the 2, but this is the y-intercept, and we're only interested in the x-intercept. So this is going to be x plus 1 in order to get my -1, or it's going to be, let me not put it like that. Let me go x minus -1, and this one is going to be x minus what?
X minus 4.
Perfect. Yes. And so now we can clean this up a little bit because minus and minus is a plus. Now, what do I have to do now with this 0, 2? What do I have to do with that bit there?
You need to sub it into y.
Perfect. Yes. So this is 2. Now, this is going to be a times 0 times 0. Wait, no, I lie. Sorry, I'm making things up. I'm having a moment. Definitely time for a break. 0 minus 4. Are you okay with that?
Yes.
Okay, so this is going to be 1, and this is going to be -4. And so if I bring the -4 across, it looks to me like A is what?
If you bring the y across, wait, I'm still calculating.
You 4. So what I've done is I've brought
It's gonna be 6.
okay, but remember, this is a multiplication. So what we do is we actually divide both sides by -4. We don't add 4 to both sides because it's a multiplication. So the question is actually going to be A is 2 divided by -4. And what's that going to be?
It's going to be 1/2, if I'm not mistaken.
Yeah, -1/2 or -1/2.
Yes.
Fantastic. Thank you so much, Ms. Eho. You've been very helpful. So the final step now is we have to unpack the top bit, and then we're going to take a break because we're working hard here. If I want to unpack this top bit, let's just make sure I see where everything has come from. Here's my -1/2, which is here, which is here. The x plus 1 was there, the x minus 4. What do I have to do to get this into standard form now? Show me in the chat, or maybe tell me with your voice. What do you think I have to do to get this into standard form now? Okay, let's go to Vuyi. Vuyi, what do you think we do? Can you hear me? Okay, I think we have audio problems there, but what I was going to suggest is we multiply out. So we get x times x, then we get minus 4x. That's for this multiplying. Then for this multiplying, we get plus 1x and then minus 4. And it's a bit messy, so you have to do some algebra, but that's why you're here to learn. So minus 4x plus 1x is minus 3x, minus 4. And now what about this lonely minus a half in front? Well, it needs to be included. So we get minus a half x squared. Minus times a minus is a plus, so plus 3 over 2x. And then I need you to help me with your calculator. What's minus a half times minus 4 going to be? So minus a half times minus 4. Well, I don't think it's going to be 8. It's going to be 2, and it's going to be positive 2. Yes. So the equation of this graph is this. So what did we do? That was a bit harder. Well, we started by writing it down in root form. And then what we did was we found A, and then we put A in here, and then we got our standard form equation down here. All right, everyone, I've worked you very hard. It's time for a break. And so what I want you to do is I want you to stand up. Simone, don't get a fright. I'm not sure if all the classes do this, but we do a little bit of an aerobics break in between. So let us stand up. And what I want you to do is I just want you to swing your arms, do whatever does it for you. Just relax a little bit and just get your body moving. I like to turn around, literally unwind, but do whatever works for you. And then I sometimes like to roll my shoulders, put my head out in front, so do that. And then sometimes I like to do a bit of small circles, going into big circles. And then I change direction, big circles into small circles. And then just take a nice deep breath. There we go. Okay, now for some high heart rate activities, we are going to do 20 air skips. So get ready, get your virtual skipping rope, and let's go. 1, 2, 8, 10, 16, 17, 18, 19, 20. And then hopefully have a sip of water if you've got some water nearby, and hopefully your brain starts to say thank you to you and starts to reboot itself for the second part of the lesson. Before we do that, I want you to solve me a Maths 24 puzzle. So just show me that you can find 24 using those 4 numbers. And if you really, in fact, I'll put both on the screen, but we're just going to do the red one unless someone stumbles across the blue one's answer. What do we think the answer is for Maths 24 for this? Who has an idea? Who can solve the red one? Mainly the red one that I'm after. Can we make 24 using 5, 5, 1, and 9? Okay, Lalita and Kumar. Oh, there's 2 different ways. Wait, the one way that's proposed is, okay, it's not a 6, it's a 9, unfortunately. So the line is always at the bottom. So this is a 9. It's not a 6. I'm going to give you a hint. What if you went 5 plus 1 to get 6? So then you've used 2 of them. What can I do from there to get to 24? So I've used 2. I've got to use the 9 and the 5. Pop your answer in the chat, or maybe you can tell me, you can put your hand up. Who feels like they know? Aha. So Rosario says 3 times 7 is 21 plus 3. You're right, Rosario, but I don't see a 3 because you've got 4 and 2. So that's a bit sneaky. Okay. So what I was going to say is I was going to say 9 minus 5. Oh, there we go. And then Bonga has found it. 9 minus 5 is 4. And then 4 times 6 is 24. So well done, Bonga. You are the Maths 24 champion for today. Okay, back to our lesson here. What I want to do is I want you to try and find me the equation of the parabola going through these points. So you know that it's going through x-intercepts -1 and 3, and it goes to the point 2, 1. Find me the equation of the parabola that goes through these points. And I'll even leave up some of the old work to help you. So over to you guys. I'm going to get some water as my throat is feeling a bit sore. Simone, just remind me at the end of the lesson today, we must do a poll. We had a technical problem on Monday, and so we must just remember to take a poll that I might forget at the end. So if you can remind me.
Will do, Peter.
Cheers. Let's see what our first steps are here. I know it's going to look a little bit like that. And sometimes what I like to do is I write down the point I'm going to sub in. So I know the point 2, 1. I write it on the side so it's there for easy reference. Maybe you can tell me in the chat, what did you get for your A value? So I guess this would be 3 and this would be -1. So we get 1 equals -3a, but now we have to divide both sides by -3. And so a is -1/3. Now you still have to give me the equation of this graph. And there's a little bit of work to still do. So I want you to do the work and find the equation of this parabola in standard form. What I think you should do is you should open up a big bracket and multiply these terms first. So the final answer should be minus a third x squared plus 2 over 3x plus 1. And the reason I have pluses is you have a negative in front and a negative inside for these ones. And so that's why when you multiply them. Also, if you're not very good with fractions, don't be afraid to use your calculator to do this. Okay. So the final answer should be that. Give me a thumbs up if you're feeling okay with this work. Give me a thumbs down if you're feeling a bit lost. Okay, so I can see we're like halfway there. We're not perfect yet, but we need to practice this some more. Now, we're going to practice another one, but what's going to happen is instead of giving it to you in form like we did now, I'm going to give it to you in the turning point form, and it's actually a little bit quicker this way. So the same ideas are still need to be practiced. So those who are not feeling sure yet, don't worry. This is actually easier than the one I just showed you. You did the harder one there. Okay, so here's my example. If they give you a drawing and the drawing only has 2 points, you may be saying, well, how do I figure the equation of this parabola? But if one of the points is the turning point, then you are in business because the turning point makes life easy. So in this example, I need to find what A is, I need to find what P is, and I need to find what Q is. And if I figure out those 3 things, I can figure out the equation of this parabola. Okay, so let me start with the easiest one. If you look at this graph, its journey in life has been to go 3 units across, or 3 units to the left, and 1 unit up. That is the shifting that has happened. So if I want to represent that in this graph, I can't do anything about the A. But if it went 3 units to the left, this has to be x plus 3. Because remember, it works the other way around to the root. And the Q value has to be 1. Right? And that's why if you worked backwards, you could find the turning point by going minus 3, 1. But now you have the problem of this A value. How do you think I'm going to get the A value with what remains? Who would like to give me a hint? Who feels like they might know how I would get this A value with the remaining information? Tsigavatso, let's go to you. What do you think I should do?
So I think you should substitute the point 1 is to 5.
Yes.
5 y and 1 is x.
Perfect. That is very good advice, because whenever a point is on the graph, you can sub it in here and it makes it true. And so that was the only other information that we had. Okay, now I want to know from everyone in the class, what is A going to end up being? I want you to work out what A is going to be for me. So we have to be careful. This 1 is a bit sneaky on the end here. So I'm going to bring it across to start with. I'm going to go 5 minus 1 equals a times 4 squared. And that's going to give me 4 equals 16a. And now I have to divide both sides by 16. And a is going to be 4 over 16, but that can be simplified to 1 over 4. So I subbed in my point, which was 1, 5. So here is my, let's use a different color. There's my 1 for x, and here's my 5 for y. When I square something, 4 times 4 is 16, and then the 1 comes across and becomes minus. So the equation of this parabola, we don't have to put it in standard form. We can put it in the alternate form. The equation of this parabola is going to be a quarter, which is the a we worked out, x plus 3 squared plus 1. Okay. Now, using what I've just shown you, I want you to attempt to find me the equation of this parabola in the gray block. I'll leave the working out on the screen. Can you work out what the equation of this parabola over here is? To ask yourself, what's the first thing I did last time? Didn't I ask myself, how did I get to this? How did the turning point move here? And how did that help me? That's what I want you to think about. Itumeleng, I have a question about the last equation we solved. Itumeleng, put your hand up and I can unmute you. I'm happy to answer it, or you can message me directly and I will answer it audibly, whatever works for you. Okay, let's see. Itumeleng, if you just put your hand up in the audio, I think you're putting your hand up in the chat. If you put it up in the participant stream, then we can unmute you. It almost like I think it says ask to unmute. Can you do that? And then, or put your hand up like you're voting or something. Because I see your hand, but I'm not sure how to unmute you. Okay, for those who are working on this one, I think we all know there's going to be an A, but the question is, what is going to be over here? And I think this should be a +1, and this should be a +6, but we still have to find A. What do we think A is? And what point have we got? What is the coordinate for here? Well, that looks like the y-intercept, which to me should be 0, 3. So Annie, I was just thinking about that. If you look at this point, this is like a sneaky way of telling you that the coordinate 0, 3 is on the graph. Don't worry, Jumaling. It's we can always try another time, or put your question in the chat if you can. Okay, so now I'm going to make the y3, and this is going to be 0. To make sure I subbed well. I'm pretty sure I did. There's my 0 for x. There's my 3 for y. And we get 1 squared is 1 plus 6. So we get 3 minus 6 equals A. And so A must be minus 3, which Solele and Iazi and Mbali and Zanele have agreed with me. So what is my final equation? It's going to be y equals minus 3 x plus 1 squared plus 6. And that makes sense because if A is an unhappy or it's a negative, you can see the graph is the unhappy shape. Okay. Everyone, I think you've done really, really well today. I just want to do one more question before we call it a day. I want to ask you, what is the range of this graph that I have just put on the board here? What is the range of this parabola? Can you write down what the range is of this parabola? I'd love to see if you can answer that question. Simone, we can, let's just finish this one and then I'll go and ask Tumeleng while we do the poll. We'll ask if Tumeleng wants to ask a question. Okay, what is the range of this graph? So ask yourself, is it a happy or unhappy? Does it get really high or really low? And where is its limit? That's what I want to know for this graph. So if I look at this, this looks like an unhappy graph, and unhappy graphs or like a ball through the air, they only get to a highest value. They never get above that. And so we can say it's always less than the highest point. So y should be less than or equal to 6. Or if you use the interval notation, it should be like that. All right. I feel like we've done a lot today. And so I don't want to overload your brains in any one day. Remember, you can rewatch the session if you feel like you need a bit of extra time on it. But Simone, if I could ask you to please click, just say the poll if you can share the poll with the students. And then in Tumeleng, I think you had a question. So if you can unmute still, then we can try that. Otherwise, maybe we can just try in the next session otherwise.
Peter,
Yeah.
there's a few polls here. I'm not sure which one, the pace poll.
Ah, good. Okay, I see. There's all sorts here. Hey. Let's have a look. Wait, okay. Let me try and launch it myself and see if it goes to the students, because we were having some problems last time.
Okay, no problem.
And it doesn't seem to be launching. Let's have a look. Try this. Otherwise, I think probably it's gonna, maybe there's some technical, let me delete some of them. But otherwise, I think, yeah, everyone, there seems to be some problem with the, oh, there we go. I got it to work. Okay, what would the domain be is the question from Annie. So the domain with the parabola is actually any real number. So if we look at a parabola, any x value can go into this parabola. And so even though it doesn't look like it, these arms keep going out kind of sideways forever. So the domain would be x is any real number for a parabola, except any x value is valid. There's no limit there. It's only the y value that's limited. Yeah. Okay.